Okay, so observe the first geometry we will select as a rectangle. So this rectangle, it will have the dimension 900 by 80 mm. Okay. So this rectangle we need to select. So for this rectangle, the length is 300, 300 and 300. So this total will be 900. And this height, it is given as a 80 mm. So dimension will be 900 by 80 mm. Then second geometry we can select. So if you observe the geometry, so from this point, so basically this shape is a trapezoid. Okay. So if you observe in the front view, so the shape given in the figure, it is the 3-dimensional. So we need to observe from the front direction. So from the front direction, this is the rectangle 1. This is having the dimension 900 and this is equal to 18. Okay. Then we have trapezoid shape. So this is the central axis. So we have the shape for the trapezoid. Okay. So this trapezoid we can divide into two geometries. So first is draw this perpendicular. Okay. So this will be right angle triangle. From this point, draw the second perpendicular. This is again a right angle triangle. And we will get one rectangle. Its dimension will be, so this dimension is given. So this is 100 mm. Then this is equal to 360. Okay. So name this. This is rectangle 1. This is right angle triangle 1. This is right angle triangle 2. Okay. And this is rectangle 2. So we will get the rectangle 1 dimension is 900 by 80. Then we have to add the second geometry. So it is rectangle 2. Its dimension is 360 into 100. Then add the third geometry. So it is right angle triangle and dimension is 1 by 2. So basically I am writing the area. So 1 by 2, its height is 360 into base. So base is, if you observe this is 300. So this total is 300. Okay. So from 300, you subtract this 100. So remaining is 200. Okay. So this will be 200 by 2. So this is 100 and this is 100. Okay. So area of that right angle triangle will be 1 by 2, 360 into 100. And again add the right angle triangle 2. And dimension is same. It is 1 by 2, 360 into 100 mm. Okay. So in this way, we will get the required area. So basically this required area is nothing but the cross-sectional area of the concrete beam. So this is the required area. Okay, so we have to add rectangle 1, rectangle 2, right angle triangle 1 and right angle triangle 2. So refer this geometry. Okay, so we can take this axis that is the central axis, as a y-axis. So we will make this geometry as a symmetric about the y-axis. And from this point, draw the horizontal axis. So this is the x-axis. Okay. So we have already studied if any geometry is symmetric about the y-axis, then its x coordinate will be. So what is the value of x coordinate for the geometry symmetric about y-axis? Yes, you can give the answer. So center of gravity of this geometry will lie on the y-axis only. So we don't know exact location along that y-axis, but we know that center of gravity will lie on the y-axis because it is symmetric about the y-axis. Okay. So for any point lying on the y-axis, its x coordinate, it will be 0. Okay. So directly we can write x bar, it is equal to 0 without any calculation. Okay. Now the remaining part is we have to find out the y coordinate, that is the y bar. Okay. So for the y bar, we need to prepare the table and then we can do the calculation. Y bar is equal to summation ai x yi divided by the summation of the area. Okay. So prepare the table to find out the y coordinate. So first geometry is the rectangle one. Its dimension is, this is 900 by 80. Okay, so get this value. Then second geometry, this is the rectangle 2 and its dimension, this is 100 by 360. Third geometry is right angle triangle. So it is area 1 by 2. Base height is 360 and base is 100. And last geometry is again a right angle triangle having the same area 1 by 2, 360 into 100. Okay. Now just observe the y coordinate. So for the rectangle 1, so this is the rectangle 1 at distance 360. So its one side or the base side is at 360 mm. Okay, so this is 80 mm. Then this is the y axis and this is the x axis. Okay, we need to find out the distance of the center of gravity. So this is the center of gravity of this rectangle. So let us take this as a G1. Okay, for the G1, this is the y coordinate. So this y coordinate will be, this is 360 plus we have to add this distance. So this is 80. So this will be 40. So 40 plus 360. So yi is equal to 360 plus 40. So that is equal to 400. So you can write here This is 400. For rectangle 2, so rectangle 2, so this is the rectangle 2. This is x-axis and this is the y-axis. This is center of gravity for the rectangle 2. So this is G2. So this distance is nothing but the y coordinate, distance along the y-axis. So this is yi. This height, this is 360. So this will be 360 by 2. So it is 180. So for rectangle 2, yi is 180. For right angle triangle, so this is right angle triangle 1. And this is second right angle triangle. Okay. So this is location of the center of gravity. So let us take this as a G3. Okay. So we need to measure this distance to get the y coordinate. So this distance we know by the formula, this is equal to h by 3. So this is the h height. So h height is 360. So this will be 360 by 3. And this total distance, this is equal to 360. Okay. So to get the yi, we can subtract 360 minus 360 by 3. Or we can directly find out this distance. So this is equal to 2h by 3. So this is h by 3 and this is 2h by 3. So this y coordinate for the rectangle, so I will write here y3. This is equal to, first formula is 360 minus h by 3. Okay. And second formula y3 is equal to 2 into h by 3. So 360 divided by 3. So we will get the same answer. So right there, this is 360 minus 360 by 3. So finally we get the same answer, 2 by 3, 360. And for last rectangle, right angle triangle, yi is same. Okay. And then find out this product. Get this summation AIXI and get this summation area. Okay. And then find out the y coordinate. That is the y coordinate.